All right, so I was just welcoming you all on a Saturday morning. Thank you for making it here. And before we begin, I would like to announce that we will be recording this session for company records. So that's just a disclaimer. And I am Bhargavi. I handle digital marketing for Fibonalabs. To give you a small intro about Fibonalabs and what we do, we are a design-led development company, and to summarize in short, we're a bunch of people that absolutely love what we do. And before I introduce our speakers for today, to those people who are new on the Microsoft Teams platform, I would like to take you through a couple of features that we could use during this session to keep it interactive and to make sure that none of us are sleeping on a Saturday morning. Yeah. So, like I said, on your far right corner, you have an option called reactions, where you could encourage our speakers during the session and give them a thumbs up, clap, or even laugh. And that's something that would keep us going and keep us energetic. And we also have the chat option. So you will be on mute throughout the session. So if you have any queries or any questions, feel free to drop it in the chats and we will take it up in the last 15 minutes of our session. So we do have a Q&A. So we will be taking up all your queries so you can drop in your questions over there. And we also do have a couple of polls that will appear on your screen throughout the session. So you could take part in that and share your thoughts as well. And now moving on to introduce our speakers for today. So we have Suresh and we have Sneha. To tell you a little something about Suresh and Sneha, let me begin with Suresh. He's our Director of Technology and Analytics. He comes with an experience of 15 plus years in this subject matter of expertise. And apart from being the tech genius that we all know he is, here's a little something that most of us don't know about him. He loves walks. And when I say walks, it's not the normal morning or evening walks that we generally take to keep fit, but I'm talking in hundreds of kilometers at a stretch. So, yeah, that's Suresh for us. And our next speaker for today is we have Sneha. She's a backend developer at Fibonalabs. She comes with an experience of 3+ years and she's an amazing person. And when you don't find her writing all those codes that I don't personally understand, you will find her buried in books. So she's an avid reader. So yeah, that's Sneha for us. And this is Suresh. So now over to Suresh. Suresh will be taking on from here.
Thanks, Bhargavi, for a very fun introduction. Um, Let me proceed further. So let's get started. If you can share the screen, we can get started. Cool. Okay, so keeping the audience group, the mixed group of audiences, I wanted to start with a little bit about what is serverless basically, and that can set the context a little more clearly for everyone before we deep dive into how are we going to implement serverless application based on any cloud platforms. Um, so, in a simple analogy, when I try to say what is a serverless, does it mean like we don't have any servers in place in the world? It is going to run on its own? No, not that way. So there is nothing called really at a word serverless. It is meant to be like as a developer really don't need to worry about what I should do in server, how I should maintain, how I should maintain infrastructure, or how I should think about scaling it. Like there is a lot of other question which comes on normally for the infrastructure engineers. All those things were not required for anymore for the developers. Developers can directly go operate very closely along with the serverless based application. And that is what meant to be a serverless. Just a simple analogy, if I say, we have everything as wireless in today's world, but there is some tons of wires everywhere here and there, which we may not be able to notice. So we'll be getting the direct benefit of what are how to use those applications rather knowing how these things are happening behind the scene. So I believe that sets the context of what is serverless and why it is meant as serverless. So the developers are meant to focus more towards code, not on the infrastructure. That's a point about it. Yeah. Moving on to how did we reach to the serverless? Over a period, this is not something which happened just like that. Uh, Immediately, these things happened. One, there was the traditional server mechanisms which was there for a very huge amount of time until this decade. It was going through with the traditional server mechanism because everyone is worried about protecting their own data and keeping their security policies and everything is intact. And small companies also were forced to go on get their own servers and keep it in their own premises and maintain it with a different set of group of people to make sure that their applications are healthy and running and serving the purpose what is meant to be. And slowly the evolution behind started from moving from on-premises to go into in a hosting at a data center level with the shared data centers. And then if the client base are pretty huge or the application base are huge, there were a lot of people who were owning their own data centers and hosting all their different application which is sharing the same data center. And further on, when it grow further, the concept of why are we using a shared space and also having shared information also between, there is a possibility of improvement over there. That's where the concept of virtual machine and virtualization came in place, and that helped us to go to the place of having our own kind of like small operating system or a virtual machines to start operating all our applications from a with a very similar way fashion from evolution of on-premises to data center to virtualization. And then further, we reach the space in cloud, infrastructure as a service. That's where we started thinking through how we can start believing ourselves in providing all our information into a different third-party cloud provider who manages this whole infrastructure on behalf of us, and our applications are ran in their infrastructures. And further to that, again, the concept of function as a service. Basically, we today call with different names, Google Cloud Functions or Lambdas in AWS, and different cloud providers gives the different names over there. And that is where we came to the evolution of function as a service, and today we are calling it as a serverless. Moving on to the next slide. So if I quickly give a very simple comparison, you can go through this. The slides will be shared to you guys even after this presentation. Um, there is a quick comparison. If you see the serverless computing, how it can help us to optimally maximize our potential with the existing things what we have in place currently, from there to reach us to go pretty high. So in terms of scalability, in terms of security, in terms of the investment, these are the various parameters we see. The bare metal is our traditional servers, and then goes with the virtual machine and container. You can clearly see there is a the time taken for a application to boot and get started is going drastically down when we reach the serverless. And of course, there will be a lot of challenges and all. Sure, those also should be taken care. But at a average, when we started seeing, this is how the serverless and containers respond to the boot time, and also the app development lifecycle, deployment lifecycle. Sorry. So that also goes to a very shortened, because we have the leverage to push our things to a serverless very quickly, which is very hard in an earlier time. And we don't need to have a dedicated systems, and all the resources are calculated based on the usage base, which is pretty much helpful for the in terms of the cost things. And also it is helping us to go into the scalability mode. Moving on to the next. So there are a few advantages which I already kind of like covered in our previous explanations. It helps us to manage our service completely, and the connections, you don't need to worry about whether it is connected to network or not, and it helps us to scale, and also your availability and resiliency, all those things also can come at a very great part for us in the serverless computing. And at the end of the day, we are primarily, we are allowing the developer to focus more onto the developing the apps, not rather thinking of production, moving or deployment too much on that part. And at the end, we are paying only for the resources what we are using through serverless computing. And it comes to with certain disadvantages too. Uh, there are certain things I can say as uh, at a very high level. Say when we are going with AWS or Google Cloud or Alibaba Cloud, um, we are tend to write our own functions based on the environment and the infrastructure what is being provided by the separate these vendors. So our services and our functions are going to be running in their environment, which means we are actually utilizing their infrastructure to design our services and make use of it. It may be their own authentication systems, or it might be their own databases, and it might be a different mechanism of their existing infrastructure which is being utilized. We are kind of get locked in one of the vendor once we go inside. It's going to take a while for us to, if we need to move from one cloud infrastructure to other, we need to have more planning and more structured ways to plan ahead for that, particularly for a migration of cloud from one vendor to another vendor. And obviously, there are other issues also, which is in terms of securities and multi-tenancy. Uh, I wouldn't say these are only disadvantages. There are ways to even overcome that, but at high level, these still exist in the serverless world, uh, because we are going to take our data into a cloud provider who's not going to be, it's not as safe as I keep it in my own on premises, or I cannot rely on that part. If I think that my data is very important for me, how should I need to go for? Probably the private clouds and other things have to be come into the picture in those areas. And allowing multiple services to share between the same shared resources, that kind of like comes with the multi-tenancy issues and all. So that's kind of like at a high level setting up the context of what is the serverless computing. And moving further from here, I would like uh, to share a few more thoughts before I move pass it on to Sneha. uh, when do we use serverless computing? Kind of like when we have a lot of bad jobs, and it is going to run at 12 p.m. in midnight, or like in midnight sometime on 3 a.m. in the morning, based on the certain frequency. For that, either we can use our own old instances to run the things, or else like we can use serverless, which is more optimal and very powerful for us to run concurrent and parallel batch jobs, which can load the data to pump to our systems and do ETLs in behind the scene at a very low cost. And any kind of multimedia task, which is where we see serverless as a very good thing. It can help us to do the same kind of a long time process of doing things at a different occurrence. It can happen on its own, which is very helpful in terms of cost and productivity also, because we are not talking about only that is a limited part. We are talking about it can go to any number of powerful processing which can happen with the serverless, which is just still in control with the infrastructure level. And we are building a chatbot, or having our REST API and any web apps, and setting our mobile backends. Can be many things. And on top of it, our CI/CD integration pipelines also can be set with serverless, which is beautiful in terms of utilizing the maximum to the maximum level of things in the serverless world. So that's about what I can conclude in the serverless. And I'll pass on to Sneha further to take on what are the serverless frameworks. And she's going to pick on the framework and go further to next thing and see how we can deep dive, how do we set up, how do we run, and how do we make it simplify our day-to-day activity using serverless from a developer perspective. Over to you, Sneha. Thank you.
Thank you, Suresh. Thanks for the introduction and then discussion regarding what serverless computing is. I hope I'm audible to everyone. Yeah. So the next topic, which we would be discussing about is, if we recap, we had discussed what serverless computing is, what are its advantages, what are its disadvantages, and where and like at what is the application of serverless computing. So now we'll dive deep into how do we write serverless applications. So the very first thing, the very first framework which comes to our mind is something called serverless framework. So serverless framework is a web framework which was written using Node.js, and this is openly this is available on the net and it is open source. And this framework is what we use to write applications which are deployed in a serverless manner. So then, the serverless framework can not only be used for deployment into AWS, it can also be used to be deployed into other cloud service providers like Microsoft Azure, IBM Bluemix, Google Cloud, all that. So serverless framework is a generic framework, and this we can use to deploy our serverless applications to many different types of cloud service providers. So moving on. So what a serverless application is. So we came to know that a serverless framework exists, which helps us in writing serverless applications. The very next question which comes to our mind is, what is a serverless application? So a serverless application is any normal application, for example, our maybe our Zomato app or any app. How it is serverless is the backend developers are not managing the servers and the scaling up of the database and anything. The backend developers are not managing. So there is a particular way of writing those kind of applications. So to write those applications, we use something called Lambda functions, or maybe if we are into AWS architecture, we would be writing something called Lambda functions. And so our application will be a set of these functions, and these functions are associated to a particular API. For example, if we take into consideration the Zomato app itself, I'm sure there would be an API which will list out all the food items and all the menu items, right? So in the backend, if that app is considered a serverless, they would have various Lambda functions associated with that API. And this is how it then turns out to be a serverless application, just for an example. And so when did the serverless framework come into picture? The serverless first was introduced in 2015 by a developer called Aws Template, and initially it came into the market with the name of Jaws. Then moving on to the next. So so serverless framework. Serverless framework is available in for many different cloud service providers. So we can write our serverless applications and then deploy to various different cloud service providers like AWS, Azure, Alibaba Cloud, Cloudflare, even Google Cloud. All these types of clouds, we can use the serverless framework, which is internally written in Node.js, and then we can use that to deploy our serverless application to any of these cloud service providers. So the very next thought which comes to our mind is, if so many infrastructure providers are available, how do we actually differentiate? Where do we inform the serverless framework that we will be using AWS or Google Cloud or something, right? So for that, every serverless application, while we are deploying it, we have a template file for that. So in the template file, we would normally list out all the backend APIs which are needed for the development. So along with the backend APIs, there will always be a key or a parameter in the template where we can mention the provider name. So for example, if we are using the AWS architecture, we would mention our infrastructure provider name as AWS. And whenever we run the deploy command on a template like this, all the APIs and all the Lambda functions which we have mentioned in this template get deployed to the AWS cloud in a serverless manner. So in this way, we ourselves as backend developers don't have to manage the scaling up of any of these servers. AWS will be handling it on our behalf. So this is how we will do that. And moving on to this is just a small example of a serverless application, just to give an idea of how it will. You can just to bring a picture in your mind. So, for example, this we can imagine like maybe Amazon. We are trying to purchase maybe a book over Amazon. So how we would do is the client is we would open the browser, we would log into Amazon, and we would see a list of all the products. So in the backend, what would be happening is the API for the listing of products would be hit from the front end. Whenever they see the products in the backend, the data is getting returned to the browser this way. So in a serverless architecture, what would be happening is whenever a user opens a particular page, and if the APIs are there to show or to list out the items, what would happen is a concept called API gateway comes into picture. So what API gateway is, we would be seeing further in the demo, like I'll be explaining in the demo as well what API gateway is. And just here, a small introduction of API gateway. API gateway is a service provided by AWS, which helps in providing the routing to all our APIs and associated Lambda functions. So basically, if we have a route called list products, then list products will be associated with a function which will fetch the products from the database. So to make a proper route for this, a domain name, then a route, and then actually render the data over the browser, we use something called API gateway. So this is how whenever we hit a URL, we would fetch some data and we can see that data on the front end, right? So API gateway comes into picture in such a scenario in a serverless web application. So this is an example of that. Then moving on to the next. Okay. So here we come to the main concept of this webinar, which is called AWS SAM. So SAM stands for Serverless Application Model. So just to recap what all we did, first we discussed serverless computing, then we discussed serverless framework, and then we are coming to SAM. So what is the difference between serverless framework and AWS SAM? So serverless framework, as we saw, we can write our serverless applications using serverless framework and deploy it to various cloud providers, right? Even AWS was a part of that cloud providers. But what is the speciality of SAM is, with SAM, if we already are on the AWS architecture, it makes it very easy for us to deploy our applications to the AWS cloud service very easily. Why? Because AWS SAM is the serverless application web framework provided by AWS itself. So all the AWS services which we would normally use in our application, it makes our job very easy to integrate them in our product, and we won't have to write long lines of code which we would have to write if we were using the serverless framework instead of AWS SAM. So just the major difference between both of them is, if we are using AWS as our cloud service provider, we should definitely go for AWS SAM to write our serverless applications as compared to the serverless framework, which is more like a generic framework. It can be used to deploy to other cloud service providers as well. So that is the very first differentiating point between serverless framework and AWS SAM. Next, we move on to, like here, since I've mentioned, there are two major components of AWS SAM. So first is something called a template. And second is the AWS CLI. So when we move on to the next, here the very first component of AWS SAM is mentioned. So here it's called a template. So since templates are there in serverless framework as well, what is a template is, from the backend, the main purpose of development is we would be creating some APIs which would be fetching data from our database, or maybe we would be processing some logic, would be computing some data, and they would be returning data to the front end or the client side, right? So where do we write those APIs and how do we deploy those APIs? That is where the template comes into picture. So AWS template is nothing but a collection of all the APIs and all the AWS services which we would need in our application. So if you see in this example below, there are many different things which we have used here. One would be like, we would mention the stage. Stage means on what stage we are deploying the APIs. Like we would have different environments like dev environment, test environment, prod environment, all this. So we would be here, we would be deciding like on which stage we are deploying these APIs. Then we would have the API gateway. Like I mentioned, API gateway, what API gateway would do is, it will take all the APIs mentioned in this particular template and provide a route for them to render. And it will, after deployment, it will provide us with the API endpoint, which we can then return to the client side, and they can then integrate it in their side of code. So API gateway is there. Then we have triggers. We can write triggers here, and then we can also write the actual APIs. So hello world is the actual API which we have mentioned here. Yeah, so then we can move to the next component. Okay, the next which we have here is AWS CLI. AWS CLI, this is the second component of the AWS SAM. First component was template. We wrote all our APIs in the template. What second thing we would do is we would now need to write down the commands. We would have to write down the commands where we would deploy. Like we have around two major commands for deployment in AWS SAM. We would use a SAM package command and we would use the SAM deploy command. So we need an interface to write these commands. So that's where AWS CLI comes into picture, which is the command line interface. So here we would invoke our Lambda functions, we would package and deploy them. And this is where AWS CLI, the purpose of AWS CLI comes into picture. So next is the most common SAM CLI commands. So like I was mentioning, we would have a command line interface, and in the command line interface, we would be writing various commands which would help us in the deployment process. So these are like whenever we are using AWS SAM, these are some of the most common commands we would use. So we can use SAM init to initialize our project. Then we can use SAM local start API to locally test our APIs using Docker. And we can use SAM logs to check logs if something has gone wrong while deployment. We can use SAM package, which will create a zip file of all our code. And we can use SAM deploy to finally deploy our code to the AWS cloud. So these are some of the major, most common commands we would use while we are using AWS SAM. Okay. So now, since we started off with serverless framework and then now we have come into AWS SAM. So the very first thing which would come into our mind is what is the difference between both of them? What is the difference between AWS SAM and what is it? How is it different from serverless framework and why we should prefer SAM in some situations and serverless frameworks in others? So I would take three major points where we can clearly understand the difference between them. So first is resource definition. So what is resource definition? What do we mean by resource definition is what are the different if you are using AWS, we would be using many different services of AWS. Like we can use the S3 bucket provided by AWS, we can use the SNS, we can use DynamoDB, RDS, all these different services provided by AWS. If you're using SAM, it's very easy to plug and play these services in our template because we would have to write very few lines of code because AWS SAM already knows these services. But if we are using serverless, which is more of a generic generic framework, we will have to write a lot of lines of codes just for it to make it understand that it has to use RDS service, it has to use DynamoDB service, all that. So usually the level of writing the code, even the length of the code would be too large as compared to the usual AWS SAM template. Then the second and one of the most interesting points about SAM is the local development. So whenever we would write some APIs, we usually test it on Postman and then only we would deploy it, right? So SAM makes it very easy for this because it will simulate the AWS cloud environment using Docker containers for us. So we would just have to start our Docker and locally we can test the APIs. And once we are clear that the APIs are working correctly, we would then deploy them to the AWS cloud. But if we are using the serverless framework, it's kind of difficult for us because we have to install a lot of plugins just for us to test the APIs locally because it has to simulate the AWS environment for us locally and it's a hassle when it comes to serverless framework. So that is the second major difference. And third is the deployment process. So as I told earlier, in SAM, we have a single command for deployment, which is the SAM deploy command. And then we have a single command for deployment in serverless as well, but there is one advantage when it comes to serverless. So usually like in our template, if we have some 5-6 APIs and we have made a change for only one of the APIs, still we would have to deploy the whole template when it comes to SAM. But in serverless, we have methods where we can only deploy the one API which we have made some change in. So that's an advantage in serverless, which hasn't yet been developed in SAM. So this is like the overall difference between AWS SAM and serverless framework. And if we are already using AWS cloud, then it's very much, it makes a lot of sense for us to use AWS SAM since it makes it easier for us to even locally deploy our APIs, even integrate with other AWS services. So that's the recommended way when it comes to AWS architecture. So then moving on. These are the benefits of SAM. Just like I said, single deployment configuration, then it's an extension of AWS CloudFormation, and local debugging and testing is very easy. Then we have deep integration with other development tools. Even we can use AWS services also in our integration. And what do we mean by CloudFormation is, this will be more clear when I take up the demo. So there I'll be explaining what is CloudFormation. So AWS SAM is kind of an extension of CloudFormation. This I will be explaining when I take up the demo. So let's move on to the demo. So I'll be sharing my VS Code. Just give me a moment. I guess I'll need to plug in my charger. Just a second. So hi everyone. I'll be sharing my VS Code, and I'll be taking you through one of the two of the APIs which we are going to deploy together to the AWS cloud, and I'll be explaining what is the process behind the deployment and how do we actually test these APIs. I'll be explaining that. So the very first thing when it comes to AWS SAM is the SAM template. So this is the template file. Yeah. Okay. So this is the sample project which I created for our demo for today. So what is the agenda for this demo is, we will be deploying two APIs to the AWS cloud, and we will see how that deployment happened, how we could test those APIs locally, and how AWS is providing us a authentication mechanism through which we can make sure that our APIs are not open and are quite secure with the use of authorization and of the ID token. So very first thing which comes in the SAM, as I mentioned, there are two components of SAM. One is the template. So very first is this template. If you see here in the template, I have mentioned a few things like stage. So in the global section, we need to mention something like this stage, in which stage we are deploying the APIs. And then in the timeout, we would mention something in seconds. So for example, here I've mentioned 30 seconds. That means one API will keep on trying to execute. If it is not able to execute, it will keep trying till 30 seconds. And after 30 seconds, if it's still not successful, it will then throw an error as Lambda execution timed out. So that is the purpose of this timeout here. And runtime means in what language I'm going to write the code. So there are many languages supported by AWS SAM. So we have Python, we have Node.js and all. So the current project which I have worked on is written in Node.js. So I've mentioned the Node.js and the version of Node.js as well here. Then we have few other parameters in the template as well. One would be the Cognito user pool ARN. So what does this mean is, so every time, every API which we would be deploying to AWS Cloud needs to have some security feature attached to it. So that security comes into picture through Cognito user pool. So Cognito is a service provided by AWS, which works like a user management tool. And every time a user signs up to our application, an entry of that user gets created in Cognito, and the ID token will be generated for that particular signed up user. So this token we will then use to validate all other APIs in our template. That way, only an authenticated and the authorized user can log into our application, and no third-party user can log in. Since if someone tries to log in also, we would return a 401 unauthorized error for that particular user. So that is the purpose of Cognito user pool ARN. Then we have something called user IAM role. So what this means is, in AWS, not everybody is allowed to deploy an application. We would have to provide few people the access of deployment, and that access is controlled through something called IAM role. So that is why we have that mentioned here. Then we have the stage name. Like I said, since I'm deploying to dev, I'll be using the dev stage. Here comes the main part of the template. Like what are the resources I will be deploying in this particular template. So in this template, I'm deploying three resources. So the first resource which I'm deploying is the API gateway. Then second is the Lambda function or the API for signing up a new user. Then the third is the login function or the Lambda function to log in a particular user and get the ID token in return. So these are the three resources which I'll be deploying in this template. So just to show you, first is AWS API Gateway. So like I said, API Gateway, what it will do is it will check for all the APIs mentioned in the template and it will provide us an endpoint for us to access that. So that is why API Gateway is mentioned here. And like I said, gateway response, that we need to define an unauthorized response as well in the template, so that if someone who is not authenticated in the user pool of Cognito tries to access our application, then we need to throw a 401 error. That is why this is mentioned here. Then we also have something called course policy, so that we should never encounter course error. That is why we would be adding the star asterisk symbol here, so that all other domains also can access our APIs easily without running into the course error. And then we would also give the name of our API gateway. The name of our API gateway here is AWS Webinar Public. So this is the name of that. Then we have the two APIs which I was mentioning. So first is the sign up function, and then we have the login function. So if we see, these are the two Lambda functions which I've been discussing about. So Lambda functions are nothing but they are the actual business logic which we would use to write in our application. They are called the Lambda function in terms of AWS context. So this is the name of the Lambda function, the sign up function, and the code. Like, where is the code available for this Lambda function? It is in the sign up handler and sign up function inside the handler. So I'll be opening the sign up function next. So if we see, this is the sign up handler, and inside the sign up handler, we have something called sign up function. So that is something which is here written here. So this is the sign up function. And so every time, and the endpoint of this API would be /signup. So it will be localhost /signup, and it's a post API. Okay, so what happens is whenever from Postman we would hit the /signup API, what internally happens is it would call this particular function and execute the business logic written inside of it. So in the sign up handler, I have written various functions to sign up a particular user to the Cognito user pool. So if we see, this is the most important line here, where I am signing up a particular user to our Cognito user pool. So just for you guys to understand the flow, what is happening, whenever I will be deploying or executing this template locally, what happens is this particular endpoint gets created with the help of API gateway. And whenever we request anything to this API, what happens is the actual business logic, which we have mentioned in the handler, gets executed and a response from the API is returned to us after the logic is executed. So what I will do now is I will be just executing this particular API locally in Postman, and I'll show you the response of it. And after that, I'll be deploying the same thing to the user, to the AWS cloud, and I'll explain the deployment steps as well. So the very first thing we need to do is first step is always building the code. So here in the first terminal in my VS Code, I've started running the npm run build command. So it has built all the handlers in my code using Webpack. It has built all these handlers. So currently, whatever code is available here is my latest version of code, and it has built and kept it in the build folder. So if you see, there is a build folder here. This has all the handlers which are already built by Webpack here. So this is that. Then I'll be opening another terminal in VS Code. And here what I'll be doing is I'll be executing this SAM local start API template.yaml command. So what happens when we do this is, if you read the command properly, it says SAM local start API template.yaml. What does this mean is, SAM will invoke the Docker container locally and it will simulate as a AWS cloud environment. And using this, we can execute the APIs in template.yaml file without having to deploy it to AWS cloud. So this way, we can test our APIs locally. So I'll just execute this command and I'll show you. So whenever we execute this command, it will return us two APIs, which are mentioned in the template. Okay. So whenever since I hit on enter, you can see it has returned these two endpoints for us, and these two endpoints are the two APIs, the sign in sign up API and the sign in API written in this particular template. So it will say both are post APIs, and it will say that this is the path for the API. So now what I'm going to do is, since these paths are seen, I'll go to Postman and I'll try to hit the particular API. So the very first API which we saw in the output was the sign up API. So I just pasted it here. And what I'm doing is I'm signing up a new user into our AWS user queue. So email can be anything. I'll give maybe user 5, user 6 as the email ID, and password can be same. So what I will do is I'll send the request. So once this happens, we will get a response from the API, which will say user successfully created or confirmed in Cognito. So let's wait for the response. Yeah. So once the API is executed, we got the response as user successfully created and confirmed in Cognito. And also in the VS Code, we can see that it has shown that it has mounted this particular build file of the API and it has executed the logic behind. And then I can log into my AWS login, and I'll just refresh this page and you can see that user 6 got created. So if you see, here is the user 6 which got created and the status of the user is confirmed. If you see, so what I did was I created an API endpoint for signing up the user. I gave it a particular parameter. I gave my username, I gave my password, and I could successfully sign up the user. So next API which I will be showing is the login user. So what I'm going to use is in the same template which I showed below, in the same template file, I have a sign-in function as well, right? So now I'll be hitting this endpoint as well from Postman. So for that, I'll copy this user 6 email and I'll go to my sign-in API. So this is the sign-in API here. And here, what I'll do is for username, I'll be giving the username as 6. So here, since I signed up the email as user6@gmail.com, so this is how I will be hitting enter and I will be getting ID token and access token for that. So what I will do is I'll be storing this ID token somewhere in my code, and then I will show how this ID token can be used to authorize a particular user to access our APIs. So yeah, so now this API also got executed and we got the ID token for this particular user. So this is like the access token for our user 6 user, which we just signed up to Cognito. Next, what I will show you is the deployment. So this was our local testing. Now I will show you the deployment of this, and next I'll show you how we can use this ID token. So for deployment, what we have to usually do is so since I've already deployed this code just before the demo, I will have to just add some small console.log maybe somewhere here, just so that AWS understands some change has happened in the API. Otherwise, what AWS would say is that there is no change in the API, so it won't deploy. So I wouldn't be able to show you the deployment. So that is why I'm just adding one console log to make sure that AWS deploys the API to our API gateway and the AWS cloud. So now what I've done, I've just made some change. And now I'll show you the deployment process. So for deploying AWS, we need a deployment to AWS. We need the template file where we have these two APIs, and then we need the deployment script. So in deployment script, what I told was for SAM, we need two important commands. One is the SAM package command and one is the SAM deploy command. So what happens is cloud formation comes into picture here. So what cloud formation is? Cloud formation is AWS's way of managing all the resources we would need while deployment, and it will automatically work on the scaling of it. It will automatically ask for whatever resources we have mentioned in the template. It will commission all those to us. And basically, cloud formation is a service which handles all the AWS resources required for us in our deployment process. That is why all the deployment commands are related to cloud formation only here. So first deployment command which gets executed in our deployment script is AWS Cloud Formation Package command. So what this does is whatever API code I have written, it will package that in a zip file and it will upload that to the S3 bucket. So what is S3 bucket? S3 bucket is a storage service provided by AWS. So every time we deploy our code to S3, deploy our code to AWS Cloud, what it does is it will create a zip using the package command. It will create a zip file of our code and it will upload that to a S3 bucket. And then the next step would be AWS Cloud Formation Deploy. So what happens here is AWS Cloud Formation Deploy is going to access the zip file which was created by the package command, and it is going to render all those APIs, and it is going to use the API gateway service to create the endpoints of it. And basically the final deployment process of actually creating the APIs or updating the already existing API happens through the deployment command. So this is what. So these two things are the most important things needed for our deployment. So now the next in the actual deployment, what we can do is I'll be opening the Git bash here in my repository. Since I'm in my AWS webinar repository, here I've opened the Git bash and I'll be running the deployment script. So basically I'll be running this deployment script, and once I run that, it will visually, like it will guide us what all it is doing. So it will have a clear idea, like we will get a clear idea what is happening. So I have executed the deployment script. We can wait for 1 or 2 seconds. It will start explaining what it is doing. So yeah. Okay, so it is almost done. So if we read step by step, the first step it is doing is it is uploading our code to S3 bucket, and it will say successfully packaged artifacts and wrote output to the output file called sam.yaml. So what happens here is in our script, we would have given what is the input file. Input file is our template.yaml. And what is the output file? Our output file is the sam.yaml. So after, why we need the output file is sam package command, after it has created the zip file, it returns a response which needs to be stored in some output file. That is why we need the output file as well here. And then if we see here, what it is doing is it is executing the deployment command. So after it packaged all the artifacts are the resources we have used in the template. And after it has packaged those artifacts, it has deployed it. It has used the AWS Cloud Formation Deploy command. And after that, it is saying it is waiting for change set. Change set is it is checking whether any API has changed or not, and whether it needs to create a new resource or it needs to update an existing resource. It is checking all that. And finally, it would say that successfully created, updated stack and the stack name. So stack is something, stack is a service, or a stack is an entity which will have all the resources which we have mentioned in our template as a single entity. So why stack has come into picture is this stack is what is actually getting uploaded to our S3 bucket. So every time we deploy, a new stack gets created in the S3 bucket, and it's usually helpful if we are debugging, if some error has happened while deploying, we can easily go and check what stack was created and were there any errors while creating. So stack is the latest version of our build code present in our repository. So finally, it has successfully deployed it. So I'll show you where we can see the APIs. So since the endpoints here were my localhost endpoints, right? So this is like my localhost and / sign-in route. We can actually find the proper route, like the actual deployed URLs for these. And that we can find by going to the AWS API gateway. So since we used API gateway to provide endpoints for all our APIs, we can easily find these endpoints by seeing the API gateway in our AWS login console. So I'm searching for the AWS API gateway service. So in the gateway, we would have the two gateway names created. So the gateway name mentioned in my template here. In my template, I had mentioned the name as AWS Webinar Public. So if you see here, the name is AWS Webinar Public. So what I will do is I will log into my API gateway and I will check for the AWS Webinar Public API gateway. So let's wait till it loads. Yeah. So if you see, there are two gateways. AWS Webinar is another gateway which we will use for our Get Users API, and AWS Webinar Public Gateway is what we use right now for our login, for our sign in and sign up function. So I'll be logging into this, and once we log in, we can see the actual endpoints which it has created, and we can test those endpoints as well once we log in. If you see here, two routes got created, sign-in route and sign-up route. And if I click on the post here, it will return the endpoint of it. Okay. Let's wait for it to come up. Or else like I already have those pasted here in my Postman. So by the time this loads, I can show in the Postman itself. So from here, like once we click on this post, it will return the actual deployed URL, like what is the deployed URL for this particular API. So, so if we see here, dev, and if we see post here, this is the actual deployed URL, like invoke URL, HTTPS, this path, right? This is the actual path, which after deployment, our code logic stays here. So what I'll do is I'll copy this and I will paste it here. So this is the sign up deployed URL which we have. So here as well, if we try to sign up a user with this particular username, it will execute the same way it works in our local environment. And now our API got deployed as well. Similarly, if we use the login API, here a sign-in API, same way we can use the deployed URL for sign-in as well, and we can use the credentials through which we had already signed up before in the previous API. So this is how we would actually deploy any API, any serverless application written using AWS SAM. And one last thing which I would like to explain in this demo is, where do we use these ID tokens which you are seeing here, right? How does this provide us a security layer for our APIs? So for that, what I will have to do is, I have another template available with me, which has the users API. Which will return basically, which is going to hit the RDS database, which I have configured for this particular demo, and it's going to return few users present in the database. So how that works is, so this is the template. I'll be showing what all we have written here. So this template is different than the previous template. Why? Because in this template, I have added the security layer of authentication. So in the previous template, we signed up user and then we logged in a user. In this template, what I'm doing is I have everything is same, only one extra parameter I have added, which is regarding this auth section here. So auth section is, I have mentioned that for every API, the API gateway needs to check in the user pool whether this particular user exists or not. And if he exists, does his ID token is his ID token available or not? And if that token is available, then only return the proper response of API, else return 401 unauthorized. So this is that. and I'll just quickly show you the get API for that. So this is the get API. What this get API will return is it will hit my RDS, like my RDS database, and it will fetch the list of users, but it will not fetch that publicly. I have added the layer of security, which is of the Cognito ID token. So until and unless I provide the ID token of a user in my Cognito, this API will not return the response. So just to give you guys a demo of that, I'll help show that in my local itself. So this is the users API / users get API. And now in the authorization section, what I can do is bearer token. And here in the bearer token, I will be providing the ID token which I got before for one of the valid users. So I'll be pasting all of this in the error token section of the API. Yeah. So now I'll be hitting the endpoint. Yeah, so if you see, it returned me all the users present in my database. It would say, what is the Cognito sub ID, what is the user email, what is the user phone number, all these things it has provided me. Then I'll show you what happens if I give a wrong token. I'll try to remove the starting two characters of this token, and I'll again hit the API. It's going to return me a 401 unauthorized error. So you can just wait for it to show that. I guess it is not considering the bearer token, or I can use the deployed URL as well. So here I'll be giving the wrong token and I'll send the request. Let's wait if it, yeah. So here we got the 401 unauthorized error. Since I gave the wrong token, it didn't return any data to me properly. And whenever I gave the actual ID token, it returned all the data present in my database. So this is the layer of security which was provided through Cognito, that if that user is there in Cognito, only that particular user should be able to access the data in my database. So this was the small demo which we had planned for this webinar, where we showed the deployment process and one or two APIs written in AWS SAM in a serverless Node.js architecture. And all this code will be available in a GitLab link along with the presentation which we have. So you guys can even try it out if you want in the future. So next is just the conclusion, which I already discussed. Like we discussed serverless computing, then serverless framework, then AWS SAM, and a small demo project on that. So that was the webinar about. So hope you guys enjoyed it. So over to you, Bhargavi, now.
Yes. Thank you, Sneha and Suresh, for the wonderful session. So we now will move on to our Q&A session. But before that, we do have a feedback form for you guys to fill out for us. I'll be sharing that on chat. Do take out a few seconds and fill it out for us. And we're also active on social media. I'll be sharing the social media links on the chat as well. So you can follow us and stay tuned for more updates regarding our next webinars and other sessions and events that we'll be conducting. So if you have any questions now, you can post that on chat, and Suresh and Sneha will be more than happy to answer the questions that you guys have. We have a question from Ravi Teja. So Ravi, I have also allowed your mic. So if you want, you can also unmute yourself and have a conversation with Sneha and Suresh.
Yeah, I'm just reading the question. It's still loading for me. Yeah.
Oh.
Yeah. So Sneha, you mentioned.
Hi, Ravi.
Hi. Thanks for the wonderful session. So Sneha,
Thank
you
you.
mentioned about creating an authorization layer for the last one.
Yeah.
So There are different types of authorizations as well, right? Can we also set it there, which type of authorization we want and what type of, in case if you use any authorization of 2.0 or something, can we set the grant
Yeah.
types or something like that?
Yeah, we can do that. Even AWS has different types of authentication. Like if we don't want to go with Cognito, we can go with a service server key that is also available. And if that is not there, even we can use our traditional JWT, our OAuth, anything is allowed in the template.
Okay, so it is just about placing a command of what type of authorization to
Correct.
be.
Yeah, exactly. And we can even have our own custom authorization if we need. The auth flow, we can have our own customized way in that. Yeah.
Okay, got it. Thank you.
Thank you. Bharti, should we wait for some time? Meanwhile, like I would like to inform that all this code which I demoed and even the PPT which we have will be available on GitLab, and we will be sending out a mail soon after this session, and you guys can access that. Yeah. Okay. Suresh, like we have a question regarding various types of clouds. So, what do you think is the most popular cloud?
At this point of time, if you ask me, the most popular overall at a public cloud service is AWS and Alibaba, and then further comes to the Google Cloud. So at a mass range, when we see it is still predominantly captured by the market by AWS and Alibaba at a very big time. And then now slowly Oracle and IBM also is coming up to the ladder. In fact, even Red Hat also have their own cloud system. So even though there is a lot of systems, still quite a big number is chunk is with AWS and Alibaba and Google Cloud. Hope that answers your question.
Yeah, I guess that answers it. Then we have a next question where Mukesh is asking us how can we achieve middleware kind of functionality with serverless architecture. So usually like middleware, whenever we think of it's in the Express server, where we would be writing middlewares. So we can do the same in our serverless architecture as well. And how we would do that is we can decide like the order of Lambda execution. So usually like whenever a Lambda function executes, it's independently executing. But there are many ways where we can decide after this Lambda this should be executing. We have step functions and all for that. So there are many ways we can even achieve a middleware kind of functionality in AWS as well. Okay, we have another question where Smith is asking us how the memory management is handled while we are using serverless. So in serverless, since we are not handling the servers and even the scaling up of the architecture, how AWS is doing all that is we have S3 buckets and we have all these, even the Lambda functions, even whatever we deploy the Lambda functions, we have various parameters there provided, and we can enable the auto scaling of it, like it will adjust if it needs more memory. And even S3 bucket, even database, all these services, there is an option where it will expand its usage if more load is coming to it. And when it comes to Lambda function, we can even manually go and increase the timeout, the memory of it. So with all these methods, the memory management is kind of easily handled by AWS, and we don't have to worry much about memory handling of that. Yeah. So another question we are getting is how can we handle large Lambda functions? So like I just said, there is a minimum limit for a Lambda function memory. There is a default limit. So it's around 28 MB, 128 MB. So if our Lambda function is too large, like recently I was working on the PDF generation from backend. So the memory management was a lot, like the memory it needed was a lot because the libraries which I was using was very huge. So I was using Puppeteer and all that. Excuse me. So for that, what I had done is I separately spinned out a separate project just to generate the PDF. And within that way, all the AWS resources were able to run smoothly without timing out and all. And the memory even I increased around 512 for it to execute. So this is a way we can handle large Lambda functions. Thanks for the questions, guys.
Do we have any more questions from the audience? You guys can still leave us your questions on chat. I guess looks like everyone is quite clear with the concepts explained by Sneha and Suresh. So, and everyone must have already planned their Saturday afternoon, I'm assuming.
Yeah. Yeah.
Yeah. So, just want to say thank you to all of you once again for taking out your time and joining us today, this morning, for this session. And we look forward to having you again in the other sessions that we are planning to conduct. We'll keep you updated. And yes, thank you so much. And do fill out the feedback form for us. I've already shared the link on chat. So yeah, see you guys again. And a very happy weekend to all of you. Yeah. So thank you from
Thanks, everyone. Thanks, everyone.